Hey pre-calc students, welcome to today's lesson on 6.2, the area of oblique triangles if you have side angle side. So quick reminder, oblique means that none of the angles in the triangle are 90 degrees. So most of you guys have learned that area of a triangle is 1/2 base times height, right? But when you have a triangle that's labeled as SAS, side angle side, there is another formula you can use that requires the use of sine. So as you can see in front of you, right, here's the formula, important to know how to use. Most of these formulas in this unit, guys, are going to be given to you, so you just have to make sure that you understand them and how to use them. So if you read it from left to right, the area of an oblique triangle can be found by taking half of, remember this is SAS, so let me draw a quick little picture of what that would look like, just as an example, side, angle, side. So the two sides and the angle between them. Okay, so the way you would find the area of a triangle that is oblique, you would do half of the two sides multiplied, so 1/2 times side, and the sine of the angle between them. Okay, so again, super, super important. Feel free to circle this, highlight it, point arrows to it. Okay, so let's get started. It says find the area of each triangle, round sides and angles to the nearest hundredth, but round area to the nearest tenth. Quick reminder that the units for sides are going to be given. So if you look at example 1, they're telling you that they're measuring in inches. Example 2, measuring in feet. So when you find the area of example number 1, you're going to put your units as inches squared. And when you find the area for the triangle number 2, you're going to put your units as feet squared. Okay, so first things first, you want to draw a quick picture, quick diagram. As most of you remember, I tend to kind of just try to be consistent with my drawings. They don't have to be accurate, but feel free to adjust them so that they are. I'm going to fill in the important information given to me. Little b is 5 inches. Okay, so in order for me to find the area of an oblique triangle, I need to make sure that I have two sides and the angle between them. So right now, if you look at it, this is angle, angle, side. So that's not enough for me to be able to use the area of an oblique triangle, the one that is listed at the top of your page. Okay, so this is AAS. I need to figure out how to find missing pieces so that I can have enough information for side, angle, side, which are two sides with the angle between them. Okay, so go ahead and pause the video right now and ask yourself, what pieces should I find? Now remember, we've been working with law of sines, so using the law of sines, what pieces would I need to find to convert this to a side angle side? Press play when you're ready to check. Now, some of you might have said, hey, what if we find that other angle? Big A. So you can definitely find big A by taking 180 and subtracting the two values that you already have. And that would give you 71 degrees. Okay, and feel free to fill it in. But as you notice, we need side, angle, side. So at least you now have some options, right? You can either find little a or little c. Because if we can find, for example, little a, then that would give me side, angle, side. Side, angle, side. Or I can find little c. That would also give me side, angle, side. Okay? So for this one, I chose to find little a. But again, this is doable with other options. So sine of 71 degrees over a equals sine of 65 over 5. Okay, so go ahead and solve this. Remember, you want to cross multiply. I like to put the singletons in front of the product or multiplication when I do each diagonal. So I'm going to put the 5 in front of sine of 71 and the a in front of the sine of 65. Then you divide by sine of 65. Okay. Take your time, make sure that you're rounding to the second decimal. So everybody should be calculating this, right? So you should have a calculator in front of you. You should be typing all the buttons necessary and practicing for muscle memory. I got 522 inches. So with this, it is enough for me to be able to use or to find the area because now I have side angle side. So I'm going to go ahead and fill in for little a the 5.22. And you can see now here's the side angle side, right? Okay, so the area of an oblique triangle is half times the two sides that make up the SAS, so the 5 and the 5.22. And the sine of the angle between them, which is the 44 degrees. Okay, go ahead and take a minute and type that into your calculator. If you have an older calculator, I would highly recommend that you put parentheses around the 1/2. Okay, for area, we're going to be rounding to the tenths place. And remember that your units are squared when you're finding area. I should be a little bit more specific with this A. I don't want you to confuse it with big A, which is in the triangle. So I'm going to go ahead and write area instead. Feel free to do the same so that you don't get confused while you're studying for your next quiz, which is next Friday. All right, when you're ready, go ahead and make a diagram of example 2. Remember, I'm not picky about how accurate your diagrams are. My suggestion is to always just be consistent. If this was me drawing it, it'd probably look more like this, where this is A, because it's a very small angle. B is 130, right? And here, it's B. So that's probably how I would draw it, but if you want to just keep drawing it the way we've been graphing the other ones, no problem. So A is 15, B is 130, and little c is 12. Okay. So if you look at this triangle, currently it's an AS8 triangle. Well, if I want to find the area of it, I need a side angle side. So I want you to pause the video and think about what pieces should I find in this triangle that will help me obtain two sides and the angle between them. Go ahead and push play when you're ready, but push pause right now. Okay, so let's say we want to find little a, okay? If I can find little a, I will have side angle side, Okay, now there are multiple ways to do some of these problems, right? You just got to find one way that works. Also, just as a quick reminder, you can also find that missing angle if you'd like. So what you could do if you wanted to, if you want to find the measure of angle C, take 180 and subtract the 2 that you've been given. Okay, and then you can use angle C as an option of how to set up your proportions for law of sines. So measure of angle C is 35 degrees, and again, you can go ahead and fill that in. Remember, we're trying to get side angle side. Okay, so by filling in that 35, you now have more options than if you hadn't filled it in. Now, just my brain went to, hey, let's find little a. So I found little a, but if you want to try a different combination to see if you get the same answer, go ahead, give it a try. Okay, so I'm going to go ahead and find little a. So sine of 15, we're using law of sines. Sine of 15 over little a equals sine of 35 over 12. Okay. If you cross multiply, you're going to get a sine of 35 degrees equals 12 sine of 15. Divide by sine of 35. Okay, and give it a try. Even though I'm about to give you the answer, you should still be practicing and putting this into your calculator. These are feet. 5.41 feet. Now again, if you tried a different combination, you should still get the final answer for the area. So area of an oblique triangle, if it's an SAS, it's half times the sides, which I highlighted in green. Sorry, my voice is like going. 5.41, and the sine of the angle between them. Let me zoom in. So the 130 is between little c and little a. And this is a 12, but it doesn't look like it. Okay. All right. So again, if you have an older calculator, you're going to need to put parentheses on the 1/2. But the newer ones, you can just type in using alpha y equals enter. Again, even though I'm going to give you the answer, you should still be practicing putting this into your calculator and obtaining the same result. Okay, this formula for triangles, finding the area of a triangle, is specifically for any oblique triangle when you know what SAS is, side angle side. So if you're ready, go ahead and look at example 3. Look at the information you've been given. If you notice, you already have side angle side. Side angle side, okay? So the nice thing is that this one you can find the area right away. Area equals 1/2 times the two sides and the sine of the angle between them. Okay, remember units are squared, so here they're measuring in yards, so it's going to be yards squared. Okay, everybody should be practicing this on their calculator. I got 51.9 yards squared. Okay, when you're ready, go ahead and start looking at example 4. How would you classify this triangle? Well, we have two sides and an angle, so is it SAS or ASS? Haha, SSA. This one is actually SSA, which means that we need to find some pieces in order for it to become an SAS. Now, with one angle known and no other ones, we can't use the law of sines yet to find any more pieces of, sorry, we can use the law of sines to find other pieces of information, but we can't use the 180 rule to find the other angles, okay? So if I want to use the law of sines based on the information given, and I want to find another angle, it would not make sense to find angle C, right? Because we don't know angle C or the side across from it. So that would not be a good choice to use for your proportion. Instead, you can find angle A, since we know the side across from it, and you can use the sine of 95 and the side across from it. Remember, when you set up your proportion, you should only have one missing variable or one unknown. When I cross multiply, I get 11 sine of A times 6 sine of 95. This should look familiar. We did a problem like this yesterday. When you divide by 11, you still have sine of A, and the only way to cancel that is to take the inverse sine. So I'm actually going to leave some space in front of this fraction, so I could take the inverse sine of both sides. Remember, this is the only time you use inverse sine is when you're trying to find the angle measure. Okay, take a minute, go ahead and put this in your calculator. Make sure, remember guys, I forgot to reiterate that you really need to make sure you're on degree mode always for these, okay? When you're using law of sines. Remember, we're rounding sides and angles to the second decimal and final answers for area to the first decimal. I got 32.91 degrees. So now what I'm going to do with that is I'm going to go ahead and fill it in. So 32.91. Remember, your job is to find SAS, so two sides and the angle between them. Go ahead and pause the video right now and ask yourself, okay, now that we know that that's 32.91, what would be a good next step so that I can obtain side angle side? Okay, so if we do these two, right? If we think of those two, that's not helpful right now since we haven't found the third. Is there a way for us to find it? Sure. So we can use the 180 rule now for measuring angle C. Just take 180 and subtract the two angles that we know. And that's going to give you 5209, okay? So again, now as I reflect on what I can do for next steps, now if I want to, I can use 11 and then find little c using the information given so that I can have two angles and the side between them. However, by finding that missing angle, I actually have side angle side right here. So I don't need to find little c. So just look, be aware of what you've got and what you need, right? So if you need side angle side, that's right here, side angle side. I don't have to find little c. So for the area of this triangle, I'm going to do 1/2 times the side that measures 11 meters, 6 meters, and the sine of the angle between them, which I found as 5209. Okay, go ahead and put this in your calculator and just make sure you get 26 meters squared. You could put 26.0 if you want as well. All right, guys, as always, if you need any extra help, feel free to reach out, and I hope you guys have a great day. Adios.